everyone. From today we are going to start a new subject, that is graph theory. We will start with the introduction to graphs. So what is a graph? A graph is basically, if I give you a mathematical definition of a graph, then a graph represented by G is a set of objects V and E, where V is the set of vertices V1, V2 and so on, and E is the set of edges E1, E2 and so on, right? So the elements of V are called vertices and the elements of E are called edges. So in a simple language, if I tell you, a graph is nothing but a collection of a set of vertices and edges in such a manner that each edge represented by EK is identified with an unordered pair Vi, Vj of vertices. That is, every edge is associated with a pair of vertices. Every edge is incident on two vertices or a pair of vertices. The vertices Vi, Vj, where I and j represent any random number. So the vertices Vi and Vj associated with edge Ek are called the end vertices of Ek. So those vertices which are associated with an edge are called the end vertices of that particular edge. Now the most common representation of a graph is by means of a diagram in which vertices are represented as points and each edge is represented as a line segment joining its end vertices. So as I said that the most common representation is with the help of the diagram. So this is a sample diagram of a graph. Now as I said, the vertices are represented as points. So here you can see all the vertices in this diagrammatic representation of graph are represented as points. V1 is a point, V2 is a point, and so is V3, V4, V5. Then edges are represented as line segments. So here you can see every edge is represented as a line segment. E2 is a line segment, E3 is a line segment, E4 is a line segment, E6 is a line segment, E7 is a line segment, and these line segments are doing what? They are joining the end vertices. Like line segment E7 is joining the end vertices V5 and V4. E6 is joining the end vertices V3 and V4. Every edge, as you can see, is incident on a pair of vertices. Here E7 is incident on the vertex set V4 and V5. E6 is incident on the vertex set V3 and V4. Then E3 is incident on the vertex set V1 and V2. So V1 and V2 will be called the end vertices of E3. V3 and V4 will be called the end vertices of E6. And V4 and V5 will be called as the end vertices of E7. When an edge is associated with a vertex pair Vi, please pay attention here. I am not saying Vi, Vj. I am saying Vi. That means the same vertex is repeated. When I say Vi, Vj, that means two different vertices. But when I say Vi, that means the same vertex set. That means these edge is having the same vertex twice as its end vertices. So when an edge is associated with a vertex pair Vi, such an edge having the same vertex as its both end vertices is called a self loop. The example of a self loop you can see here. Like edge E1 is having vertex V2 as both its end vertices over here. So V2 is the starting point also and V2 is the ending point also. It starts from V2 and then it ends again at V2. So such an edge which is having the same vertex as its both end points is known as a self loop. So this you can call a self loop. Then parallel edges. When more than one edge is associated with a given pair of vertices, such edges are referred to as parallel edges. With two end vertices, usually just a single edge is associated. But in those cases when with a pair of vertices or with two vertices more than one edge is associated, then such edges are called parallel edges. For example, in this figure, edge E4 and E5 are parallel edges because both these edges are associated with the same pair of vertex V1 and V3. Otherwise, you can see every edge is associated with a different vertex pair. E6 is associated with V3 and V4. So E7 is associated with V4 and V5. So all the edges are associated with a different vertex set. But in such a case where both the edges are, that means more than one edge is associated with the same vertex set, then such edges are called parallel edges. So E4 and E5 here are called parallel edges. A graph that has neither self loops nor parallel edges is called a simple graph. Now this graph that we are seeing here is not a simple graph because it is having both self loop and parallel edges. But any such graph which has neither self loops nor parallel edges is called a simple graph. In drawing a graph, it is immaterial whether the lines drawn are straight or curved, long or short. That means the shape of the graph, the length of the edges of the graph, it does not matter. It does not matter whether the lines or the edges of the graphs are straight or whether they are curved or whether they are long or whether they are short. So all these things are immaterial in a graph. What is important? Important is the incidence between the edges and the vertices. That means which edges are incident on which vertex pair. That is important. For example, here you can see two graphs. You may find them to be completely different graphs, but actually they are the same graphs represented in a different manner. So these two graphs in figure below, which you can see here, are same because incidence between the edges and vertices are same in both the cases. Now, as I told you, the shape or the size of the line segments which represent the edges is immaterial. What matters is the incidence between the edges and the vertices. So here you can see in both these graphs, do not go on the shape and size of these graphs. If you go by the shape and size, you will find them to be two different graphs. But actually these are not two different graphs. They are the same graphs drawn differently. They are same graphs because the incidence between the edges and vertices is the same over here. Like for example, you can see this particular vertex pair 1 and 4 is having a common edge. Then 1 and 4 is having a edge here also. Then there is an edge between the vertex pair 1 and 2. Then there is an edge between the vertex pair 1 and 2 here also. Then you can see there is an edge between the vertex pair 2 and 4 here in this graph. So is there an edge between the vertex pair 2 and 4 in this graph. Then there is an edge between the vertex pair 2 and 3 in this graph. So is there an edge between the vertex pair 2 and 3 in this graph. Then there is an edge between the vertex pair 3 and 4 in this graph. So is there an edge between the vertex pair 3 and 4 in this graph. So clearly you can see that the edge, that the incidence between the edges and vertices is exactly the same in these two graphs. So these two graphs are same graphs drawn differently. In a diagram of a graph, sometimes two edges may seem to intersect at a point that does not represent a vertex. So, for example, consider this particular graph. Here two edges are intersecting at this point. This point is not a vertex. These are the vertex which are represented as points. See, these points represent the vertices of the graph. But there is no vertex at this point, and these edges are intersecting at this point. Edge E and edge F are intersecting at this point, which is not a vertex, right? So such edges should be thought of as in being different planes and having no common point. Since this is not a vertex, So you should think of edges E and F or any such edges to be in different planes, and thus they have no common point. A graph is also called as a linear complex, one complex, or a one-dimensional complex, though the most commonly used name is a graph, and we will also refer it to as a graph throughout the videos. A vertex is also referred to as a node, a junction, a point, zero cell or zero simplex, but most commonly we call them as vertices or as nodes. And the other term used for an edge are branch, line, element, one cell, arc, and one simplex, but the most commonly used term is edge, and sometimes we also refer to them as arcs. So in this video we will refer to the graph as graph, the vertex as vertex, and the edges as edge, and no other name.